Hello everyone. In this video we are going to be looking at physics practical question 2 NECO 2023, which involves rectangular glass prism. So here we have the rectangular glass prism and all the other necessary parameters on it. So let us quickly read through the question. Use the diagram above as a guide to carry out the following experiment. Trace the outline ABCD of the rectangular glass prism on the drawing paper provided. Remove the prism. Select a point N on AB such that AN is about 1/4 of AB. Draw the line LNM. Also draw a line RN to make an angle theta equals 35 degrees with AB at N. Fix two pins at P1 and P2 on the line RN. Replace the prism on its outline. Fix two other pins at P3 and P4 such that they appear to be in a straight line with the images of the pins at P1 and P2. When viewed through the prism from the side DC, remove the prism and the pins at P3 and P4. Draw a line to join P3 and P4. Produce line P3, P4 to make the line DC at O. Draw a line to join NO. 8. Measure and record the values of MO and NO. Evaluate phi is equal to MO over NO and cos theta. Then we are asked to repeat the procedures for 4 other values of theta is equal to 65 degrees, 55 degrees, 45 degrees, and 35 degrees. In each case, we are to evaluate phi equals MO over NO and cos theta. So this is what I'm going to do, show you how to manipulate this result.
All right, now we have our readings and a table of readings. So this is what we are going to do in this video. We are going to manipulate our reading. Now, by the use of simple geometry, we'll be able to get the readings without doing much of the looking through the mirrors at the glass and also doing too much of a measurement, though we're still going to carry some measurement. So the first thing I'm going to do as usual is to draw the outline of our glass prism. So let me draw the outline of this glass prism. Okay, so I'm using a pen so that it's going to be visible. So this is my outline. I will show you that I will never return this block to this outline again. That will be the end. So the next thing I have to do, from the instruction that we are given, we are to measure 1/4 of the length of this. Okay, about 1/4 of the length of this. So I'm going to measure this. So I'm measuring this to, this is 10. 0.1, 0.2, 0.3, 0.4, 0.5. So I'll just divide that by 4. 10.5 divided by 4. That is almost 2.6. So I'm come to this place and measure 2.6. Okay. So this is 2.6. It's not compulsory that it must be here, but you are to measure something that is close to that. Then I'm going to take my normal. Okay, place this on top of this. So we'll take our normal at this point. So ensure that this dot here is at the point that you mark there. Then this 0 mark is on top of this line. So this is my 90, so I'll put a dot here. So I'll come to this place. I'll draw this downward. Okay, so this represents my normal, and the normal is L, N, and M. Okay, now we are going to use a bit of geometry. So let's look at the angles. In fact, what I'm going to do is this: 75 degrees. I'm going to prepare a table. Now, we know that for a glass, the refractive index n is equal to 1.5. Okay, we can use the idea of this to write that the refractive index of the glass n is equal to sine angle of incidence divided by sine angle of refraction. Now we know fully well that sine from geometry, sine theta is equal to cos 90 minus theta. In fact, that is why you were asked to evaluate cos theta here, because the angle that you were given was the angle that the incident remains with the what? The boundary of the what? The glass, not with the normal. Okay, so it therefore means that sine I, let me put I here, okay, so it therefore means that sine I is going to be equal to cos theta. So it therefore means that I can also use my n as cos theta, that's the angle given, these angles here, divided by sine r. So all I have to do now is to look for r. So I have sine r is equal to cos theta divided by n. N is 1.5. Okay, now to find r, or you can leave you can just set your r, you can just leave your sine r this way, okay, or you can go this way and look for r is equal to arc sine, the sine inverse of cos theta divided by 1.5. In fact, this is exactly the same as r is equal to arc sine 1 divided by 1.5 cos theta. If I divide 1 by 1.5, that's going to give me 0.6666, 0.666. So I'll just put that 0.67. So I'm going to have r is equal to arc sine inverse of 0.67 cos theta. So we either be using this or sine r equals, so if I divide this again, I'm going to have 0.67 cos theta. Now, why did I say this? Now you are coming to this place, you are going to measure. So if you are going to use them, I'll teach you how to use either of the formula, either this or this. So we're going to use either of that. Now, so I'm going to do this. I'm going to measure this. Now, this is what we are looking for. You know that at the end of the day, we're going to draw some lines through this place, and we're going to have this. So we're going to have something of this nature, a right angle triangle of this nature. This nature. So this is my arrow. Now look at this. This is opposite. This is adjacent, and this is hypotenuse. Okay, now if you have this, you can see that, you see from that from this table, you are asked to evaluate phi is equal to mo over what? No. So then you see that if this is n, this is m, and this is o, you see that it is this mo divided by n, which is what? Opposite over what? Hypotenuse, which is what? Equal to what? Sine r. Okay, so now if I'm going to use this, the first angle here is 75 degrees. So my r is going to be equal to arc sine, 0.67 times cos 75 degrees. So if I work this out from my calculator, I'm just going to press, you can just do the 0.67 times cos 75. That's going to give you 0.1732. Just from the calculator, press shift, sign, answer. So that's going to give me 9.98. So the first arrow I'm going to get is 9.98, which is approximately equal to 10 degrees. So I can measure 10 degrees on my diagram. So this is what I want to actually achieve. So you can go this way. Now if I want to get the second arrow, this is arrow 1, first value for arrow. The second value for arrow, I'm going to do 0.67 times cos 65. That's going to give me 0.28. Okay, then I'll take shift, sign, answer. So that's going to give me 16.4. okay, degrees. So you see now I have two angles, 10.0, 9.9. You can take 9.9 or approximate to 10.0 degrees, 16.4 degrees. Now let me pause at that. Now when you are using this method, it therefore means that on this part here you will regularly draw angles like this. From here you regularly measure angles from this point. The first one is 10 degrees. So I'm going to do this. I'm going to measure 10 degrees from 90. So it's going to be at 100. So I'll put it at this point, or you can just do 9.9, which is not possible for you to get. So I'll approximate that to 10. Okay. Then from here you take your ruler and join these two. In fact, you can work out all of this before you start taking what? Before you can work out all of this before you start taking it. But I just want to show something here. Now, if I don't want to use this method, here, this is what I'm going to do. So that I will not be measuring this angle with a protractor all the time. I won't be measuring this angle with a protractor all the time. This is what I'm going to do. I'm going to take the measurement of this. So if I take the measurement of this, this is exactly 6.5. So the width of this is 6.5. So I'll write that down. So it means that this is 6.5. Okay. Now we already know what our sine of this angle will always be. Okay. Now if I get the sine of this angle, if we get angle arrow from here, we got angle arrow from the first part as 10 degrees, right? Now look at this. This is what I'm going to do. You know that tan theta is equal to opposite over what? Adjacent. Now I just measured this is the opposite. I just measured my adjacent to be 6.5. So it therefore means that tan theta, the first tan theta is what? 10 degrees. So I'm going to have tan 10 degrees is equal to opposite all over adjacent, which is 6.5. So from here you can see that opposite is going to be 6.5 tan 10 degrees. Okay, so I'm going to do this. 6.5 tan 10 degrees. That's going to give me 1.15 approximately. So what am I going to do? So you come to this place. Now instead of drawing this line here, you come to this place and measure 1.15. In fact, what I have here is exactly 1.1. Now can you see what we have here is 1.15, which is approximately, you can approximate to 1.2. So what I have here is exactly 1.1. So instead of measuring the angle, I'll just measure 1.1 here, then I'll join these together like this. So let me do it for the other part. So for the other part, we already know what the angle is. The angle is 16.4. So I'm going to do, so it therefore means that the opposite is going to be 6.5 tan 16.4. So I'm going to press on my calculator. 6.5 tan 16.4. So that's going to give me 1.9. So I'm going to get an approximate value of 1.9. Okay, so I'll just come to this place. I'll measure 1.9. So put this here. And measure, this is 1.9 here. So I'll put it here. Then I'll measure this. 1.9. Okay. Now remember that, just take note that I have not done anything to this, but I'm already doing all of this. Okay, but it's advisable for you to take all of this down. Just take all the angles, take the measurement of the angle down, so that the examiner will not understand that you are doing something that is not right. Okay, that you are manipulating your results. So let's see. Let me just take all the angles down. So I'll take all the angles. This is, the angles are 75 degrees. So I'll use this. So let me take all the angles. This is 75 degrees. I'll draw one through there. This is 65 degrees, 55 degrees, 45 degrees, 35 degrees. So it's better to just mark all the angles down. Then you join this to this point. Okay, join this to this point. Join this to this point. Join this to this point. Then I'll join this to this point. Now, let me go to the next angle. So we have done for 75, 65 using both methods. Now let me go to for 55 degrees. Okay, so to get 55 degrees, first of all, I'm going to use R equals, okay, R is equal to arc sine 0.67 cos 55 degrees. Now you know you don't need to write all of this all the time. You already know what it is, so you just point from your calculator, just press 0.67 times cos 55. That gives me this. Then I press shift sine, answer. That gives me 22.6 degrees. You need not write it down. So what you now do is this, just come to this place. You know that your opposite is always equal to 6.5 tan theta. Okay, so you do 22.6 tan, that's the angle, so do tan answer times 6.5. So that will give me 2.70. So I'll come to this place again. I'm going to measure 2.70. So this is 2.567. Okay, so I'll join these 2 points. Now the next angle is 45. So what do I do? I'm going to do my formula. You know the formula. It's going to be arc sine 0.67 times cos 45. Now, so you're going to do 0.67 times cos 45. That gives me this. From your calculator, press shift sine answer. That gives me this. Then press tan answer. That will give me this. Then you multiply that by 6.5 times 6.5. That gives me 3.49. I'll approximate that to 3.5. So I've come to this place again. I'm going to measure 3.5. So this is 3.5. So I'll join it. As easy as this. Now, the next is 35. So what do I do? Our formula still remains the same. 0.675 times cos the angle. So that's cos 35. So I'm going to do 0.67 times cos 35. That's the last angle. That gives me this. I'll press shift sine answer. That gives me this. Now press tan answer. That gives me this. I'll multiply it by 6.5. So that's going to give me 4.26. So I'm going to take that to 4.3. So I'll come to this place, put it here, and I'm going to measure 4.3. This is 4.1.2.3. So I'll come to this place and draw it through this place. Now, notice that we are going to have lines coming out of there where we are going to put our pin. That is not a problem. Now, these angles here, this makes an angle of 35 degrees. with this, 45 degrees with this, 55 degrees with this. This one is 65 degrees, and this one is 75 degrees. So again, this same line will make the same angles with this, starting from this side. So this is going to make an angle of 75 degrees, because this one is 75 degrees with this side. So just come to this place, place this on top of this, ensure that the zero line and this, so count, this is 70, 75. Put a dot here and join this to this point. So what this tells you is that the angle of incidence here must be equal to the angle of emergence here. Okay? Then for the next one, come to this place and do 65 degrees. So we are going 65. This is 60, 65. So I will join this. So this one is going to be 55. So I have a 40, 50, 55. So I'm going to join this. Okay. Then the next one is 45. So I'm going to get 45 here. And the last one is 35 degrees. Okay, so this is 30, 35 degrees. Okay, so the next thing I have to do is to take my pin. I already have a hole here, just place this here, put another one here, place one here, place another one here. Just place pins like this, one pin, just place it on 2 points like this. Okay. Okay, so I'll go to this other side. I'll place pins like this. Place pins on the point that I've marked out. Place pins, place pins, place pins, place pins. Put another one here and put another one here. Now what I should have just done was to take my recording as I was measuring this. I should have just been recording them here, because I don't need to take measurement of this again, because I already know what the measurements are. Okay, so but since I did not remember to record all of that, I was carried away, so I'll just have to measure them again. You don't need to measure it again. Immediately you take the measurement from there, you already know what is. So this is 1.1. So this is 1.1. This is 1.9. Okay. This is 2.1567, 2.7. Next, we have a 3.5. Next, we have 4.3. So you see, this one was my error for me. Before I start measuring the weight, immediately I take my measurement, I should just be able to put this here. So the next you have to do, you can now come to this place and measure NO. So these are my NO. So just put this here. And if you don't want to measure, you can also come around and use that your same equation to get what? NO. Now to get NO, you can go back and do this. Sine theta, sine arrow is equal to, here, sine arrow is equal to what? 0.67 cos theta. Yes, that's sine arrow. And you know that sine arrow is equal to what? Opposite is equal to opposite over hypotenuse. It's the hypotenuse that we want to calculate. So from here you can see that opposite over hypotenuse is equal to 0.67 cos theta. Okay, now we want to look for hypotenuse. So therefore hypotenuse is going to be equal to opposite divided by 0.67 cos theta. So can we just work that out now? Now we already know what the opposites are, so let's come to this and we know what the angles are. These are theta, so this is the formula that we are using. Opposite over what? Cos theta. This is my opposite, 1.1 divided by, open a bracket, 0.67 cos 75. So that will give me 6.3. So I don't have to measure. So this is going to give me 6.3. So let's go to the next one. I'll still follow my formula. Okay, the next one is 1.9 divided by, open bracket, 0.67 times cos 65. So that's going to give me 6.7. Okay, next I'm going to get 2.7 divided by, open a bracket, 0.67 times cos 55. That's going to give me 7.0. Okay, next I have 3.5 divided by, open bracket, 0.67 times cos, the angle is 45 degrees, so that's going to give me 7.4. Okay, then for the last one we have 4.3 divided by, open bracket, 0.67 times cos 35 degrees, so that's going to 7.8. So these are my values. Without looking through the mirror, the glass, I've been able to write out my neat diagram. Now I'm using a pen, that's why the thing is, so if I'm using a sharp pencil, it's going to be neater than this, and my work is going to be faster because I will not have to be looking through and taking too many measurements. Okay, so this is how you arrive at your table, and you can now go ahead to evaluate this. And this, how do you evaluate? Just do this divided by this, 1.1 divided by 6.3, that's going to be 0.17. Take that to 2 decimal, 0.17. So these are my values evaluated to 2 decimal places or 2 significant figures. So this, you are going to evaluate this to at least 3 significant figures. So this is going to be cos. So we're going to have cos, the first angle 75, that's equal to 0.259 to 3 significant figures. So I'm going to pause it and do the others. So these are the values of cos theta evaluated to 3 significant figures. So next we're going to look at how to plot this graph.